Hi dear students. So today we will discuss the exercise portion of the chapter 12. The descriptive level questions we will discuss today. So I'll just give the directions how to do such problems, and I'll be sending the GSEB solutions also along with this video. The link is there. Just go through that link, and in that link it is clearly defined how to answer or the way how to answer the questions. So just follow that one also. So we will discuss some of the questions in the exercise portion of the 12th chapter. So first of all, the 8th question. When a 12-volt battery is connected across an unknown resistor, there is a current of 2.5 milliampere in the circuit. Find the value of the resistance of the resistor. Here the V value it is given. So the voltage V is equal to 12 volt, and the I value, current, it is 2.5 milliampere. So what you have to find? The resistance value you have to find. So we can use the Ohm's law over here, that is R is equal to V by I. So substitute the values, the V value and as well the I value you have to substitute. Remember, the I value is given in milliamperes, 2.5 milliamperes it is. So that is actually 2.5 into 10 to the power minus 3 amperes. Okay, the milli means 10 to the power minus 3. Remember that one. So I is equal to 2.5 into 10 to the power minus 3. V is equal to 12 volt. So R will be is equal to 12 divided by 2.5 into 10 to the power minus 3. So that is 4.8 into 10 to the power 3. And that is the 10 to the power minus 3 is taken to the from the denominator to numerator it is taken. So that will become 10 to the power 3. And 12 divided by 2.5 will be is equal to 4.8. So 4.28 into 10 to the power 3, that is 4800 ohm, or we can say 4.8 k ohm. Sorry, 4.8 kilo ohm. 4800 ohm is 4.8 kilo ohm. Okay. Now come to the 9th question. The question is that a battery of 9 volt is connected in series with resistors of 0.2 ohm, 0.3 ohm, 0.4 ohm, 0.5 ohm and 12 ohm. How much current would flow through the 12 ohm resistor? So we can see here we are following the series connection of the resistors. So the value of the current which is passing through each and every resistors in the series connection will be equal, and the value of that current will be equal to, or it is due to the equivalent resistance. We have to consider the equivalent resistance or the resistance due to the combination and the applied voltage. So the current value can be find in such a way, that is V by V is the applied voltage, V divided by the R equivalent. That will be the current value, and that current will be flowing through all the resistors. The same amount of the current will be flowing. So first of all, you have to find out the value of the resistance, that is equivalent resistance, RS value you have to find. So here the series combination is given, so R1 plus R2 plus R3, likewise 0.2 plus 0.3 plus 0.4 plus 0.5 plus 12. So total it will be 13.4. So R equivalent or the combination resistance due to the combination is this 13.4. Then I will be is equal to V by R, the Ohm's law you have to apply over here. So the voltage applied it is 9 divided by the equivalent resistance or the resistance of the combination. that is 13.4. So I will be is equal to 0.672 ampere, and this will be the value of the current which is passing through 0.2 ohm, 0.3 ohm, as well 0.4, 0.5 and 12 ohm resistor. The same value of the current will be passing through the resistors if they are connected in series combination. So we can say the amount of the current which is passing through the 12 ohm resistor will be is equal to 0.672 amperes. Now come to the 10th question. The 10th question is that how many 176 resistors in parallel are required to carry a 5 ampere on the 220 volt line. So first of all, we should know what should be the resistance we have to apply to draw 5 ampere current from 220 volt line. So for that one you have to use the Ohm's law over there. So R value, the amount of the resistance required, will be is equal to the V by I, that is 220 volt divided by 5. 220 by 5. So that is equal to 44 ohm. So 44 ohm is the required amount of resistance over there. So but you are given with the 176 ohm resistors, and you should connect this 176 resistors in parallel, and you have to make a 44 ohm resistor. The equivalent resistance should be 44 ohm. So as we are connecting the resistors, the value of the resistors are same, that is 176 only. So equivalent resistance value will be is equal to 176 divided by n. That means if we are connecting two resistors in parallel, that is 176 divided by 2. So we don't know how many resistors it is needed, so we are taking the number as n. So R equivalent will be is equal to 176 divided by n. So R equivalent, you know, already it is derived, that is the 44 ohm. That is the amount of the required amount of resistance, it is 44 ohm. So n will be is equal to 176 divided by R equivalent. That is actually 176 divided by 44 ohm. Okay. Then the value will be is equal to 4. So 4 number of 176 ohm resistors should be connected parallelly to obtain 44 ohm resistance. And 44 ohm resistance is required for obtaining 5 ampere current from the 220 volt line. Now come to the 11th question. That is, show how you would connect 3 resistors, each of resistance 6 ohm, so that the combination has a resistance of 9 ohm and as well 4 ohm. The first one it is 9 ohm and the second one it is 4 ohm. So first of all, you are having the 6 ohm resistors. So let us go for the 9 ohm resistance. How will you make? If you are given with the 3 6 ohm resistors, how will you form a 9 ohm resistor with the combination of these 3 6 ohm resistors? That we will discuss first. So first of all, you have to connect the 2 6 ohm resistors parallelly. And with that connection, you have to connect another 6 ohm resistor in series. So here the A, B, C, 3 resistors are there. So A and B have connected parallelly, and with that combination you have connected another, that the C, the 6 ohm C, in a series form. So first of all, the R equivalent for the A and B will be is equal to, actually both the resistors are 6. So we can say the parallelly, if you are connecting 2 resistors of resistance 6 ohm, then the equivalent resistance will be is equal to 6 divided by 2, that is 3. Now the equivalent resistance of this A and B is 3 ohm. So along with this 3 ohm, you are connecting a 6 ohm resistor seriously. So the equivalent resistance over there will be is equal to, that is series combination. So 6 plus 3 will be there. So 6 plus 3 will be is equal to 9 ohm. So you can obtain a 9 ohm resistance with a combination of a 6 ohm resistors in such a way two of the resistors, that is A and B, are connected in parallel or connected parallelly, and along with that combination you have to connect another one, that is the C, a 6 ohm resistor in seriously. Then you can obtain the 9 ohm resistance. Now the second portion of that question is that you have to obtain a 4 ohm resistance with a combination of the 3 6 ohm resistors. So here the A and B have connected, two resistors of 6 ohm are connected in seriously first of all, and along with that connection you have connected and then another 6 ohm resistor parallelly. So first of all, the series combination, the A and B, the combined resistance or the combination, the series combination, the equivalent resistance value will be is equal to 6 plus 6, that is 12. So now the 12 and 6 are in parallel combination. The 12 and the 6 are in parallel combination. So we can say the 1 by R equivalent value, or 1 by Rp, is equal to 1 by 12 plus 1 by 6, that is equal to 1 by 12 plus 2 by 12, that is equal to 3 by 12. So R equivalent will be equal to 12 divided by 3, and the value will be 4 ohm. So if you are connecting two resistors seriously, and along with that connection if you are connecting a 6 ohm resistor parallelly, then you can obtain or derive a 4 ohm resistance. Now come to the 12th question. The question is that several electric bulbs designed to be used on a 220 volt electric supply line are rated 10 watt. So the power consumption by one bulb, it is given as 10 watt. How many lamps can be connected in parallel with each other across the two wires of 220 volt line in the maximum allowable current is 5 ampere. So the maximum current which is available, it is 5 ampere. So you know that the connection here, the parallel connection is given. That means each light is connected parallel to each other. So like a way the current is getting separated, so equally separated with, because the resistance of each the resistance value of each bulb will be equal, hence the amount of the current which is distributing through the each bulb will be equal. So first of all we have to find what or how much amount of current is required for one bulb. So the power value it is given and the voltage is also given. So we know that P is equal to V into I. So for one bulb, the power consumption, it is 10 volt. So 10 volt will be is equal to V into I, where V value it is given as 220 volt. So 10 divided by 220 will be is equal to the current which is required for one bulb. So that is 1 by 22. Now you have to find out the amount, the number of bulbs that you can connect in this circuit. So here the amount of the current, net amount of the current, it is 5 ampere. So for one bulb the amount of the current required, it is 1 by 22 ampere. So you can say the number N you can define in such a way that available current, that is net current divided by the current required for the one bulb, that is 5 ampere divided by 1 by 22, where I1 is given, that is the amount of current required for one bulb, it is okay, I1. So 5 divided by 1 by 22, that is 5 into 22, that is 110. So total 110 bulbs you can connect in such a circuit. Okay. So now come to the next question, that is the 13th question. A hot plate of an electric oven connected to a 220 volt line has two resistance coils A and B, each of 24 ohm resistance, which may be used separately in series or in parallel. What are the currents in three cases? So in the first case you are connecting the resistance value separately, that means only a single resistor you are connecting. In the next one, connecting parallelly. The two resistors, 24 ohm resistors, are connecting parallelly, and in the third case you are connecting them in the series form. So you have to derive the amount of the current in these three cases. So V is given, R you can find. In the first case, R will be the 24 ohm only. So current value will be is equal to V by R, the Ohm's law you have to apply over the. So V is 220 volt, and the R is 24. So that means we are using only one resistor, a single resistor, separately. So 220 divided by 24, that is 9.16 ampere. So 9.16 ampere current will draw if you are connecting only a single resistor, or separately if you are connecting a resistor of 24 ohm in the circuit having the potential difference of 220 volt. Now if you are connecting two resistors 24 ohm, two resistors of resistance 24 ohm in parallel combination, so the net resistance will be equal to 220 divided by 2, that is 220 divided by n. Here the number of resistance connected parallelly is 2 only, so 220 divided by 2, not 220, here the resistance value is 24, so 24 divided by 2, so that will be equal to 12 ohm. So 12 ohm is the equivalent resistance when you are connecting the 24 ohm resistance, two 24 ohm resistors parallelly. Now for finding out the current value I, you can do I is equal to, that is Ohm's law, I is equal to V divided by the R. Here R it is 12 ohm, that is the equivalent resistance here. So 220 divided by 12, that is 18.3 ampere current. So if you are connecting two resistors of the resistance value 24 ohm parallelly in that equipment, that is the electric oven, then the current drawn will be equal to 18.3 ampere. As well, if you are connecting that in a series combination, that is N into R will be there. So equal resistance values are connecting. So 24 plus 24, that is 24 into 24, that is 48 ohm. 48 ohm will be there. So as the 48 ohm resistance, if it is connected along a potential difference of 220 volt, the current drawn will be equal to 220 divided by 48. So the value will be 4.6 amperes. 4.6 amperes. Okay, so the remaining questions we will discuss in the coming section. And also already I have sent the hints of the answer key of the solutions. You just go through that one and try to understand those questions. Okay, first of all, anyway we will discuss that one before the next section. As a next working day before that one, we will discuss that one. Okay, as maybe on the evening time or something, I will send you the solutions, the video solutions. So just go through that one and practice well. Okay, and present the answers in the neat and the specified way. I have already given some of the examples how to represent the answer. Okay, so go through, follow such methods and follow such path. Okay, thank you. Wish you have a nice day.